Hello everyone, I'm Leslie Wöhler from the Computer Graphics Lab at TU Braunschweig, and I'm happy to present our work called PEFS, a validated dataset for perceptual experiments on face swap portrait videos. First, let's look at what face swaps videos are in general. For these videos, the face of an actor in a video is replaced with the face of another person while keeping the movements and facial expressions of the original actor. As an example, here you can see that the face of the actor in the left image is replaced with the face of the actor in the right image, resulting in the face swap shown in the middle. As can be seen from this example, the quality of state-of-the-art face swaps is high and can be good enough to be unobtrusive and, in some cases, even undetectable for the observer. This offers great possibilities for creative scenarios like movie production, but also leads to problematic situations where face swaps are used as a tool to create defamatory video material. Even though research is focused on both the creation and the detection of face swaps, there are still many open questions on whether and how the perception of these manipulated videos differs from original videos, for example, considering conveyed realism and emotions. In order to assess the perception of face swap videos, specialized datasets are necessary. Currently, existing datasets offer great numbers of face swap videos with diverse actors, but their applicability for perceptual experiments is limited, as they are mainly used to train and evaluate facial manipulation detection frameworks. As an example, you can see two videos from the face forensic dataset. While both videos contain convincing face swaps, they also have many distracting background elements, which would make it difficult to compare the responses of participants for experiments measuring implicit responses like eye tracking or EEG. In contrast to previous work, our dataset PEFS is specifically designed to investigate the perceptual differences between original and face swap videos. As you can see in the left and middle video, we include recordings in a controlled environment, which contains a consistent background and static lighting. Furthermore, we also recorded some uncontrolled sequences, which are closer to real-world scenarios and feature movements of both actor and camera, as well as occlusions and varying lighting conditions. Finally, we performed an experiment and had participants decide whether videos were real or face swaps in order to investigate how convincing our face swaps are. Additionally, we gathered partial annotations on noticeable artifacts. So, now let's look at how we handled the recordings to obtain controlled sequences. You can see the setup used during these recordings in the left image. During the recordings, participants were asked to sit on a chair in front of a white wall and were recorded simultaneously from 3 cameras. Examples for the views of each camera are shown on the top right of the slide. During all recordings, the positions of the cameras, lights, and the chair were kept the same to ensure high uniformity of the environmental conditions. Overall, we invited 14 participants without acting experience to the recordings. We separated the recordings in 3 scenarios, designed to obtain a high variation of facial expressions. First, we asked participants to read out a text which was presented to them on a display in front of them. As you can see in the video, participants did not establish eye contact and mostly displayed neutral expressions. Therefore, this condition established the neutral baseline for experiments. In the second part of the recordings, we evoke different facial expressions and emotions in the actors using the method acting protocol. To do this, we explained different situations to the participants, which are meant to evoke 11 different conversational emotions and expressions. In the dataset, we include agreement, disagreement, cluelessness, thinking, pain, happiness, sadness, anger, disgust, fear, and surprise. For each of these, actors were asked to say the same neutral sentence in order to avoid effects of different mouth movements. In the video, you can see the actors showing agreement, disagreement, and a clueless expression. The last part of the recordings was a free interview, where the conductor tried to capture sincere emotions of the participants. Additionally, the conductor walked through the room in order to move the line of sight of participants. In addition to the controlled capturings, we also filmed some participants in unrestricted environments. These include different actions like drinking from a cup or walking down a corridor, generating challenging situations for face-swapping frameworks like occlusions, lighting changes, and camera movements. In the upper video, you can see an example where the participant wore a pair of glasses which caused an occlusion with his face, while the lower video includes movements of both the actor and the camera. Finally, we used our recordings to create all combinations of face swaps between the 14 recorded actors. To this end, we used the publicly available framework DeepFace Lab, which includes not only the neural network to create the face swaps, but also several post-processing steps like colorization, matching, or adjustment of facial contours. In order to prepare stimuli showing different levels of artifacts, we create face swaps with varying quality by stopping the training of the neural network at different epochs. As you can see in the videos, low-quality face swaps have more visible artifacts like a stronger blur. In order to assess our dataset, we performed an experiment focusing on the perceived realism and artifacts of our face swaps. Additionally, we wanted to find out which facial areas participants used to detect the manipulations. The experiment was performed online via Amazon Mechanical Turk and started with an explanation of the intention of the experiment, as well as a brief description of face swapping. During each trial of the experiment, a video was displayed by the push of a button and automatically played. Afterwards, the participants could not pause or rewind the video. In order to prevent the participants from analyzing still frame images, we removed the video after the playback was completed. Instead, we presented a screen displaying the question, was this video manipulated, which had to be answered using the options yes or no as the two alternatives forced choice task. Next, we asked which facial areas were most important for your decision, which could be answered with eyes, nose, mouth, cheeks, and contours. Finally, if the participants decided the video was manipulated, we asked which artifacts they saw. The last two questions were multiple choice and also included the option of none of the above. During this experiment, we used a subset of 11 face swaps of our dataset, which you can see on this slide. In addition to high-quality face swaps, we also included the corresponding real videos and low-quality face swaps. The duration of each video was 60 seconds. In order to avoid biasing the participants, we used a counterbalanced in-between participants design. This way, each participant either saw only high-quality or low-quality face swaps. We also made sure to never show the same participant in original and the corresponding face swap video. Overall, 44 participants took part in this experiment. Based on the answers of our participants, we find the high-quality face swaps were believed to be real in around 65% of trials, showing the high quality of our dataset. Furthermore, all low-quality videos still obtain a reasonable quality and were voted to be real videos in around 50% of trials. Therefore, there could be a good stimulus variation in experiments that investigate the impact of artifacts. We used the data of this experiment to annotate the face swaps. As an example for the results of the experiment, you can see a video that overall obtained high realness rating on the left, while the video received a low realness rating on the right. We also annotated each video with reported artifacts and the important facial areas. On the left you can see a face swap that was often reported for the blur on the face, which is clearly visible in the low-quality version while the actor is looking down. The face swap on the right side was often reported to contain unnatural movements, which can be seen in the eye region. Other noticeable artifacts of the face swap videos include inconsistent skin color, as well as contour artifacts for low-quality stimuli. Finally, the participants based their ratings mostly on the mouth, nose, and eye regions, which are generally most important for facial recognition. In this talk, I presented our dataset PEFS, a novel facial manipulation dataset which can be used for perceptual research on face swaps. It contains recordings in controlled and uncontrolled environments using 3 different camera angles and quality levels, totaling 630 videos. We also partially annotated the videos with a perceived realism as well as noticeable artifacts. We believe that our dataset is a valuable stimuli collection for various perceptual experiments, assessing the differences between original and manipulated videos. This concludes my talk. Thank you for your attention. If you are interested in our dataset, please contact me via mail to receive access to the stimuli.